front of your notebook. So, you will not have to write the definition of a polynomial for me, I promise. Those are ugly and they are kind of scary. Okay? So, if you see something like this that confuses you, what I would do is try to write it with numbers. And I'm just making stuff up. But this is just the dummy example of a polynomial. Your a sub n and your a sub n minus 1 are just coefficients. They couldn't name them all the same name. So they use just dummy representations. The 3 dots just mean you're coming on down. Okay, and again, I'm just making up a dummy polynomial. This could be a sub 1, could be an 11x to the first. What is a standard characteristic, though, is all of your exponents going down. Alrighty. And the last thing is our constant. And what I want you to recognize is that constant was your x term with the 0 power. But what is anything raised to the 0 power? Is it 0 or is it 1? 1. You won't believe how many people said 0 today. Because it makes you, you think, oh, 0, 0. But when you have anything to the 0 power being 1, that's why you end up with a constant. So anytime there's a constant in a polynomial, he was the 0 power. You're not going to have to write this for me, but that's what that represents. Doesn't this look a whole lot better than what is written up there? So, anyway, in your notes, anytime you have f of x, which is your y, equal to 0, it's undefined. It is nothing, the degree. If you have a constant, now we just talked about, that it is a 0 degree because it had x to the 0, which is 1. So that is a trick question. Anytime you have y equals 5, the degree is 0, or y equals 7. No exponent means it's a 1. That's why this guy's degree is 1, and it's a 2. In your quadratics or any polynomials, they're written in descending order. Alrighty. So, just to review, that should have been kind of familiar. The next part is our slope. How many of you are in physics again? I think several of you. Alright, so you talk about rate of change. You don't call it slope anymore, do you? It's your rate of change. For us, back in pre-algebra, algebra 1, geometry, we use the slope formula. Physics, you do change of y over change of x. Today, you're going to be given problems or statements with f of x equaling y and plugging them in for your slope. So, that's where this is bridging the gap from the lower levels to the honors pre-calc. But we'll see that. Okie doke. I prefer, and I don't know why that they didn't, you write your polynomials in ascending order, because if you get lazy and just pick the first one, that might not be the degree. The degree is always the highest exponent, and the number out front is his coefficient. That's an easy one. But did anybody get hung up on why this guy was not a polynomial? Okay, did anybody figure out why he wasn't a polynomial? Our polynomials cannot have a fraction degree. In algebra, oh, that's not in algebra. Let's do this. 25x to the 4th plus 9x squared. Did you remember that a square root was really the 1/2 power? I saw, kind of go, oh. Well, in polynomials, you can't have fractions. All the powers have to be positive and whole numbers. Somebody this morning said, well, why couldn't we do 25x to the 4th plus 9x squared, both under the radical? Well, remember, when you're under the same radical, there's an imaginary set of parentheses. So, that is why you cannot have a fraction degree. -3 from algebra, you should remember that that means it's in the denominator. You can't have negatives because it's in the denominator. You can't divide by your variable. Your polynomials are straight business, x to the positive power. Yes, Sean?
So does that mean degrees can't be negatives?
Absolutely, they can't be negatives. And like this guy, since he's not written in ascending order, hurrying through a quiz or test, you might say, oh, he's degree 2. But you got to remember the degree is the highest, and the leading coefficient goes with that guy. So there's a reason that I'm having you do some of these on your own. Because when you move on to community college, regular college, trade school, or whatever, they're going to expect you to be able to read and comprehend and do work on your own. And it's tough. It's tough to read this math stuff and understand it without it being explained. So that's why on some instances, I am going to have you read and do some of the notes on your own. Do you remember back at the beginning of the year, we said when you have an expression like this, I want your brain to interpret it as when x is -4, y is 9. You remember when I said that? And you all probably thought, gosh, she's being extra picky. Well, this is why. Because I'm not going to ask you to find me the slope of regular numbers. I'm going to give it to you like this. And if this is your x and that is your y, then you can get your 2 ordered pairs from those to do your slope. Did anybody interpret that when they read that like that? Good. That's awesome. And this might have helped you, but that's the hard part of when you do notes on your own or read the book. And like I said, when I taught at West Liv, they wanted me to cover 3 chapters a day. That was like one example from a chapter, if that. And then they don't go over homework. So you guys, I'm just trying to prepare you. But our y2 minus y1, x2 minus x1 gives us a slope of 1/2. They wanted slope-intercept form. So there's your slope. I hope if there's a problem, you would work smarter and not harder and realize if x is 0, that guy is your y-intercept. Otherwise, you would take an ordered pair, plug all of it in, and solve for b. We did this at the beginning of the year, so this is kind of a review. All right, we're getting almost done here. I know I'm talking a lot at you. This is something else that if you don't have all of this on your note card, might help you. Might help you study for the midterm or the final, especially after the summer or during the summer when if Mrs. Cotton gives you a summer work packet. Having all this down in one place may help you. You can certainly go back and do that, but the only thing we didn't highlight is the standard form. When you pull everything over to one side and set it equal to 0, you're going to have to know that. Okay. Last little thing you should have read last night is given the points, getting your ordered pairs and putting it in your forms that they're asking. So -2, 3. And 4, -5. Using those, we can find the slope to be -4/3. Point slope form we had on our very first quiz after our algebra review. Y1 and X1, picking either ordered pairs, stopping at that point is your point slope form. Solving for Y, you get your slope intercept form. So again, this is all quite a bit of review. But if you struggled with some of your homework last night, after going over this, maybe go back and look at it. The only thing new would be the general form. The general form, everything was on one side and no fractions. So they multiplied everybody by 3 and got that. Okay. Any questions? On Monday, and I'll come around today and look at your homework. On Monday, I'll get the whole packet homework. But we're only going to do to completing the square today. I think in Algebra 2, you all probably took a month or so to do everything we're doing here in 3 days. All right, so this is fast. Let me go back here for a minute and show you the funny and talk about the homework. So with our quadratic functions, the fact that it's quadratic, you know that, hopefully you know we're dealing with a parabola. Degree 2. I already said this, but I hope you know as soon as you hear quadratic, you think degree 2 and parabola. Oh, you already did it. That's awesome. Okay. Parabola. We opened up, we opened down. What you're going to learn today, though, is as we were shifting them just from the equation, you were actually dealing with the vertex. The standard quadratic form that we talked about earlier is ax squared bx plus c. And a can't be 0, because if it is, you have a linear equation, not a quadratic. That's the standard form, and you will have to know the difference. Because on Monday, we're going to complete the square to put it in the vertex form. And when we did this earlier, I was frustrated because you all hadn't learned this, and the creator of this curriculum expected you to know it, but it wasn't until the next chapter. So that confuses me. Standard form is ax squared plus bx plus c. Vertex form, we use the actual vertex point, and that's, you've been using that to graph changes, but you didn't know what it really was. In the vertex form, h and k are the actual vertex. H gets the opposite sign when you pull him out. If it's not in this form and it's standard form, you can find that, and this should not be anything too new, by taking the opposite of b over 2a. So if I give you the green form, taking the coefficients and doing this work gives you the x coordinate of the vertex. And then if you plug that answer into your original equation, that'll give you the k. When you do that, the axis of symmetry is the guy that cuts your graph right in half. That is always going to be the x coordinate of your vertex. We learned that if our coefficient a is positive, in either one, it's going to open upward. And if he's negative, he's going to open down. If I plug in 0 for every x and evaluate the function at 0, that's going to give me just the constant. Because if every x is 0, you're just left with that guy. And what you all loved at the beginning, because you did so well on your pretest. Anybody know what I'm writing? Ah, absolutely. That is one of the ways we can find the x-intercepts. Don't get so excited about it. The quadratic sound like you were getting your toenails ripped off. The quadratic helps us find the x-intercepts. The best way is on our calculators. But this is our work upcoming. Today we're just going to examine the h's and k's and work with the vertex formula. Monday we're going to complete the square to get the vertex formula. Okay? Any of this look familiar to you? Yeah? No? Well, that's okay if it doesn't. We're pretending that we're starting from scratch. Alrighty, so moving on. I don't know why I left blanks through all of this. Transformation of the parabola. It sounds like it could be a discovery show. I think at least it's not a tarantula, because I would be out of here in a heartbeat if it was a tarantula. You all have already done this. Who remembers what this negative does? Does it flip it over the x-axis or the y-axis? Yeah, remember, because if he's your x, he's outside of the house or the parentheses. I know, I'm stuck on that. Alrighty, so the negative sign is going to reflect across the x-axis. That's right. So the negative reflects across the x-axis. Anybody remember what that 1/4 does? Shrink. It's a shrink. Yeah. But it's opposite. Like I hate, yeah. Shrink. But I think it makes it look bigger. But I know. It shrinks it away. The key says 4, but that's a mistake. The 1/4, wow. Shirks. You should have, one more, you guys get a mistake point. You should have seen how I was spelling names for the formal tickets. Shirks, shrinks, sheesh. Now I'm thinking of shrinky dinks, but you all probably don't even remember what they are. Alrighty, it's going to shrink it by a factor 1, 4. The key says 4. The key's wrong. Tell me what the 2 and the 3 do. 2 and 3. Yes, dear. Yep, the 2 moves it to the right. Sure. And the 3 moves up 3. You guys already did this. So I could have assigned those last night, but I wanted to talk about them a little more. Okay, almost done. I promised you this would be easy. And Cindy's already looked at the homework. So Cindy, do you think it looks easy? Quick. Okay. Supposed to be yuck and rainy Saturday, so when you're home being bored, you can do your work. I could see a great bonus problem happening here. If I expand that x minus h squared in the vertex formula, can anybody tell me what I would get if I expand the x minus h quantity squared? Anybody know? Okay, what do you think, Chase?
X squared.
Mm-hmm.
Negative minus x8.
Yep.
Plus h squared.
Yep. I'm going to add one thing. Can you even see that blue in there? Remember, you're going to have minus 2 xh's, right? So that's it. That could be part of a bonus. Because if I write this vertex form, I'm going to write the A and rewrite what Chase just told us. And I haven't used the K. Okay. What this is, ax squared minus 2axh, I'm just distributing. It turns into, if you look, that's going to be our ax squared term. This ends up being our bx term, and that's our c. Just, takes you right to your quadratic original formula. You're never going to have to do that, but maybe for a bonus. Remember, the h of our vertex comes from the negative b over 2a. All right. I could also solve this for b. I don't know why you would want to. But you could get b to be negative 2ah if you solved it. And we learned that our vertex is negative b over 2a. And then plugging that in, you get the y of that. All right. Questions? I would mark this. I wouldn't mind putting this as a bonus for something. That's a good one. Okay. Last thing, and then your Friday is happening. I have given this to you in the quadratic form. You know A, B, and C. Rewrite it in the vertex form. Find the vertex and the axis of symmetry. So they want us to write it in that form. I know A already. What could I plug in for A? Who is he in my original? How about, is it 2? Okay. Now I need, though, H and K. But I have the tools to find it. Because H and K are our vertex that come from, remember, negative b over 2a, and then plugging that into our original. So, what would I plug in for b and a to find negative b over 2a? Anybody know? So negative 8 all over 2 times a, which that gives me, does not give me 4. That gives me 2. So that tells me my h is 2 because my vertex is hk. To find the k, you guys could have gotten a mistake point right there. I take that 2 and plug it in. So if I take my x and plug it back in, what do I get? What's my answer if I do that arithmetic? Small number. What do you get, Cohen? Did you get anything or you
Oh,
just?
I'm stretching.
Okay. Anybody agree with? 3. So, when I plug in that, I get 3. So that tells me my K is 3. And your axis of symmetry is the H and your vertex. And that is it. So 8 to 15, 20 and 21. Not a brain burning assignment here.